Hi, I'm Mike Schroeder, and I'm going to do problem 10 from 4.1. It gives you g of x equals 3 times theta to the 3/5 power, and it wants you to find the minimum and the maximum values. So the first thing you have to do is you have to find g prime of x, and to find g prime of x, you take n times 3 theta to the n minus 1 power. So 3/5 is n times 3 times theta. 3/5 minus 1. This is theta to the 3/5 minus 1. 3/5 times 3, that's 9/5. 9/5 theta. 3/5 minus 1, that's negative 2/5. So you have 9/5 theta to the negative 2/5 power. So the next thing we have to do is we need to find out where this function is undefined. So this is in the numerator right now, but we move that to the denominator to rationalize it, and we get 9 over 5 theta to the 2/5 positive power. To find out where this is not, what am I trying to say? Where this function is not rationalized, you have to find out where the denominator is 0. So, and that's when the function cannot exist. So the denominator is 5 theta to the 2/5 power. Set that equal to 0 because it can't equal 0. And then 0 divided by 5 is 0. The 5th root of 0 squared is 0. So theta cannot equal 0. So now we know that theta can't equal 0. So when we try to find our critical point, when we set our equation for g prime of x, because this g prime of x, this is the equation for slope. So our critical points would be when g prime of x equals 0, because that's when the graph, that's when the tangent line is going to be horizontal. So when we set 9/5 theta to the negative 2/5 power, when we set that equal to 0, we get 0. So we get theta equals 0. But up here, we say theta cannot be 0. And down here, we find the critical point at 0. So we know that critical point can't exist, since we already found out that there's a hole at 0. So that one's ruled out. So our other two critical points would be the endpoints of the equation. So this actually gives you, the domain is negative 32 is less than or equal to 0, or theta is less than or equal to 1. So yeah, I think that's right. Yeah, negative 32. So now these are our endpoints. So we'll plug in 3 times negative 32 to the 3/5 power, and then that equals, let's look at there, negative 32 to the 3/5 power times 3 is negative 24. So we know that there's that this endpoint is negative. This is our y, this is our x, so x comma y, and then the other point, which is 1, the right endpoint, we get 3 times 1 to the 3/5 power, and then that just gives you 3. So you know that xy 1 comma 3 is our other point. So looking at this, this would be way to the left and low, and this would be way to the right and up higher. So we know that this is what the graph looks like. The hole there. And we have 1, 3. Let's say that's right here. And that's where it ends. And then negative 32. Say that's negative 32. Negative 24 is down here. So this is our minimum, and this is our maximum. And these are the points. So this would be min. This would be equal to max. And that's everything you need for this one.